Sika gave us the tooling boards, which we used to mill a negative form out of it, so-called mold. And then we laminated the carbon fibers into that, cured it in the autoclave. They helped us find the perfect material, fitting adhesives.
A very good morning, good afternoon, and good evening to our viewers watching from all around the world. Welcome back to another episode of Better Made with Adhesive. My name is Natalie, and I'm going to be moderating you through today's episode. We are here at the Swissloop facility. Swissloop is a student-led initiative with the goal of contributing to the research and advancement of the Hyperloop technology and its applications in the real world. I am here with Janis and Yanik today, who are going to give us a little bit more details about how Sika supported with sponsoring them in their project. And later on, we're going to meet with Fabrice, who's an expert in the composite world. Janis and Yanik, thank you very much for having us today.
Thank you. Thank you.
So could you please tell us a little bit more about Swissloop?
Swissloop is a student-led initiative by the ETH Zurich. We were founded in 2016 and then competed in a so-called Hyperloop competition that was organized by SpaceX. Since then, we are aiming every year to build a new prototype to do some advancements in Hyperloop technology. It is a platform for ETH students and students from other universities to have some practice experience in the mechanical and electrical engineering department.
This is really cool. Could you tell me a little bit more about the Hyperloop Week?
The European Hyperloop Week was founded by Swissloop and 3 other teams from all over Europe. And it's a competition where teams from all over the world come together to showcase their prototype and on what they have been working on for the last year.
So I heard that you guys won several awards. Is that correct? And I would like to know what was the reason why you had the best concept and what was the reason that made you succeed?
So we have won 5 out of 10 awards.
Wow.
And the reason for this is mostly that we worked very clean. So there are like other teams putting their stuff just on the pot and not thinking through all the mountings and so on, and the cable management. Then another point is we were eager to have a very safe pot and to operate it very safely. So the jury was absolutely stunned how well we've done those procedures and how we worked around some issues. Last but not least, we have implemented many features. So levitation, a good motor, and so on. So there's a long list.
So according to my understanding, Sika supported you guys with materials. Can I know how they helped you make your pod successful with the materials they provided?
Yes, so they helped us with doing our carbon chassis. So Sika gave us the tooling boards, so epoxy tooling boards, which we used to mill a negative form out of it, so-called mold. And then we laminated the carbon fibers into that, cured it in the autoclave. Also, they've provided us with support. So they helped us find the perfect material, fitting adhesives, and also adhesives in some other areas of our pod. And they even did tests for us.
Oh, that's very nice to hear that. Why did you specifically use this process while creating your pod?
So we've used pre-pregs, pre-impregnated carbon fibers, which must be stored in a freezer. And we've laminated them into the tooling boards we've got from Sika. And this tooling board is very high-end. So that means that it can withstand 130 degrees Celsius. Therefore, we could use also high standard, so aerospace pre-preg, which is very lightweight. It also provides, at the same time, good stiffness and good strength while it's being very lightweight.
I am very happy to hear that Sika provided you with the materials to make your project successful. We're now going to move to Fabrice, where he's going to feed our knowledge a little bit more into the composite world.
Hello.
Hi, Fabrice. Thank you very much for joining us in today's episode.
Me. Yes.
Thank you. So it seems to be a very complicated procedure to do just one pod. Is there another process that we could use?
Well, first of all, composite pod is a combination of a reinforcement fabric, as Yanik mentioned before, together with a resin binder. And when the resin cured to a solid state, it forms a stiff part, which is strong and lightweight. So lightweight has been always interesting for many industries, from aerospace to Formula One and also railway, whereby they have the possibility to change some metallic parts to composite parts and gain some weight. So for example, a composite part can be 4 or 5 times lighter than a metallic part. So nowadays, especially in automotive, as more and more electrical cars are coming in the market, the weight of cars is becoming really essential for car manufacturers to save weight. So they are starting to use more and more composite parts in the body of the cars. But to make composite parts, you need composite tooling. And for that purpose, Sika has one expertise within Sika Advanced Resin, is composite tooling. So Sika is providing various solutions and materials to suit various manufacturing processes of composite parts. So we have a variety of materials such as epoxy liquids for gel coat, laminating systems or infusion systems. But we have also board materials, including the one we have provided the Swissloop with. And we have also extrudable paste. So board materials are more used for small to medium size projects, up to, I would say, a car. And then for large size projects, such as car, but also in marine racing yachts, like America Cup and so on. But also for wind energy rotor blades manufacturing, which are very large parts, then people are using extrudable paste technology for this purpose.
But it sounds like there's a lot of waste generated in this. Is the industry working on making it a little bit more sustainable?
Yes, because as you understood, that very often, even a direct mold, as Swissloop has been using, you need to make a large size monoblock of material. So there's a lot of unused material except the surface. So to avoid that, we try to develop a hollow structure. And Sika, as you know, is investing a lot in 3D printing material with expertise, of course, in concrete industry, but also in plastics with recent acquisitions, and also in thermosetting systems within advanced resin. So the aim for us is in the near future will be to develop systems where we can 3D print same material as you've been using. Instead of having a block material, we 3D print it. That will have a hollow structure, self-supporting, saving a lot of material.
Fabrice, Yanik, and Janis, thank you very much for coming today, and thank you for having us. I've learned a lot about Sika and the composites. It's great to see how Sika is supporting different projects and looking for different ways to optimize processes. Thank you very much for tuning in another edition of Better Made with Adhesive. We look forward to hearing in the comments on what you would like us to discuss in our next episode.